Good afternoon, students, and welcome to the first in a series of tutorials of working with MonoGame. This is part of the Kansas State University Department of Computer Science's Foundations of Game Programming course, CS 580, but also all of this content is being released under Creative Commons, so if you are not a part of the class but you still want to take advantage of these videos, you are more than welcome to. So, to start with, MonoGame is a platform or a library for building video games. It's based on Microsoft's XNA, which was part of their 360 launch, and once upon a time you could have written a game in XNA and deployed it to your own Xbox 360, which was a really neat feature. We started using it about that time. Microsoft went away from it when they moved forward to the next generation of Xboxes, and the open source community picked it up, which is how MonoGame actually became a thing. So currently supported platforms include Windows, Mac, Linux, iOS, iPad, Android, and a lot of the different game consoles. Notice they all have an asterisk. That's because you need to have a developer platform for doing that. You have a licensing agreement with the manufacturer of the hardware, so there's a whole process there. But if that's something you're interested in the future, if you build a game against one of these other platforms, it's fairly easy to switch. And in fact, for this class, unlike prior semesters where we focused on the Windows ecosystem, we are going to be developing our games in a more cross-platform way. So the way that we're actually doing it now will allow us to actually develop on Windows, Mac, or Linux environments, and then you can turn around and target any of those environments for your game release as well. So we need a couple things for our development. We need a operating system, and as I said, we can actually use any one of those three. We're going to be using VS Code in all of the examples. Prior semesters I used Visual Studio. If you jump ahead in the videos, you may get ahead of me re-recording those, so you may see the old Visual Studio versions. The code should be pretty much identical, but the IDE is going to look very different. The benefit of VS Code, or one of the benefits, is it will actually run on any of those operating systems, so you can actually do your development anywhere you want. Writer is one of NetBrains products. It's also a very good IDE for especially professional developers. As a novice, I think VS Code gives us a little bit more of a simple interface, and it's also free, whereas Writer you can get for free as a student, but as soon as you're not a student, they want you to start paying for it. We will other thing we'll need then, if we're using Visual Studio, is we'll have to install Visual Studio. You can actually find their download link and see for Windows you're going to download an MSI installer. For the Mac, you're probably going to download a package that you can deal with directly as you normally do, and then Linux you can run through a package manager or you can compile from source. All of those are opportunities there. For the .NET framework, you're also going to want to download the SDK, and specifically you want SDK version 9 or .NET 9.0. They are actually up to version 10.0, but MonoGame is still using version 9, which is a long-term support release, so it should be in support for some time, and that's what you'll need to install. Now, if you have been using Visual Studio, it is actually using these under the hood. It actually basically is a GUI that sits on top of the command line interface, but we're going to be working on the actual command line interface. So when you actually set those up, you should then be able to run the .NET command from your console, and there you can see, there it is. You will need to install the optionally, you'll want to install this MonoGame extension for Visual Studio. That's handy to have. It goes ahead and sets up the project templates for you and takes care of that. If you don't do that, you have to install the project templates yourself. I'm in Visual Studio. Visual Code. There we go. And you can do that with this command, and you can do this with the command line. And I've already done it, but I'll do it again just to show you what that looks like. And you can see there it says, oh, boom, 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 we installed all these things. These are basically just a bunch of tools and templates, especially for creating a blank project. And then if you want to install the extensions, you can do so there and find them. And You can also install a lot of other things. We don't actually need a lot of those or any of those at this point, so we can jump down to, let's just create a new project, .NET new MG for MonoGame, desktop, because we're building a desktop game and we're using OpenGL, so GL. And that's really, that goes and grabs that specific template that we just installed and then creates a project for that. So what I'm going to do, I like to work from the command line. You can also do this from within VS Code once you've opened it up. But I'm going to make a directory. I'm going to call it Hello Game. I'm going to change into that directory. And then I'm going to run that command we just saw, which was .NET. Helps if I spell it right. New MonoGame desktop GL, and that's going to create all the files for our project. You can see there it did create it for us, and now if I were to list the contents of the directory, or if you're on Windows it's dir is the same command, you can see now there's stuff in that directory. And if I run code, which is the executable for VS Code, and then give it a period, it wants code, and then the path to the folder we want to open up. In this case, period means this current folder that we're in. That will open up VS Code, and you can see we have our game code already there for us. And I'm going to just do a couple things. One is we're going to want something in our content folder. I'm going to use this basketball PNG, but you can use whatever image you can find or want to use. However, do be aware when we build video games, the artwork, the assets, the music, those are all potentially licensed things, so we want to make sure that we have permission to use those. And for the course especially, I require an assets.markdown file to list what assets you've had and where they came from. So basketball PNG, this is public domain and created by Eric. Let's see if I can remember how to spell Eric's last name. He was one of my students who very kindly shared this with us. And Garcia, I believe it was. And basically I want where it came from. If you pulled it from a URL, you can give us that URL, and then what licensing was involved. So in this case, he basically created it for one of his projects. I said, can I go ahead and use this with my students in the future? And he said, sure, anybody can use it, I don't care. So very kind of him to give us that. And this is just one of the things that as a class we're going to require, is that we need to attribute correctly where we got all of our assets from. If you create your own assets, then just say created by me, and if you give your identity, that's fine. And eventually when you build a video game, if you're pulling in assets other people created, you want to put those in the credits of the game itself. But we're also going to have an assets.markdown file for all of our games as we build them. Okay, so let's go ahead and get into the actual code itself. So let's see what's going on here and what this does. So you can see we have kind of the C# scripting style. This is our entry point program.cs, and it's constructing a hello game.game1. Which is an instance of this class, and then it immediately calls its run, and then that's really all that does. If we come into game 1, here we see the game 1 extends the game class. That's actually defined for us in XNA framework. That's the base part of a game. And then we have a graphics device manager and a sprite batch that are declared as private variables, and we'll be using these here in just a moment. And the graphics device manager gets initialized here in the constructor. What this class actually is it is essentially a wrapper around our graphics device or our graphics card. So it manages all the 3D rendering aspects and all the communication between the CPU and the graphics card. It is a very important piece. Then we have the content.root directory. Every game object has a content manager stored in this content property, and we're just telling it to look for content in this content folder. We'll come back to that in a moment. And then we have this is mouse visible true. This is also a property of game that just says that when we run the game, the mouse should still show up. Eventually you might want to turn that to false if you're using mouse input in your game and you go full screen. However, for debugging in early stages of development, it's very helpful to have that mouse there and be able to take it outside of your window so you can come back to your IDE. So we're going to leave that as it is for now. Then we have initialize, which initializes our game, and load content, which loads content for our game. Now you may be wondering, why do we have a constructor and initialize and a load content that are all doing setting up things for the game? And that's a very good question. They do different levels. So the game constructor is really where kind of the low-level pieces of setting up the window and the structure of how the game interacts with the operating system are generally going to be handled. Initialize is for game-specific logic, and load content is for game-specific things that require the graphics device to be initialized. Because we actually initialize the graphics device here, we're not guaranteed to exist until we get into here. So it is important that we for example, don't load textures until we have a graphics device. You can see here we're also setting up the sprite batch class, which is a class that manages two-dimensional sprites, and it helps simplify getting them on screen, and also gives us a lot of options for how to optimize how those are being put on screen. So this is basically the class, core class in XNA for doing 2D games within an actual 3D rendering environment. But it cannot be initialized until we have this graphics device, which is the essentially reference to our actual graphics device, or our graphics card. It's the software interface to talk to that. And then we have two methods, update and draw, and these are actually called inside our game loop. So every 1/60th of a second, or possibly 1/30th or 1/120th, but basically as fast as our computer is refreshing, we're calling the update and draw method. And inside of those, we would update our entire game world, and then we would render our game world. And you can see here, this basically is checking some input and is calling exit, which is a method on the game which will cause the game to close. This is essentially an escape hatch bit of code. Especially if we go full screen, we may not be able to actually manipulate the IDE or tell it to stop debugging. So having already wired into the template if we hit the escape key, we drop out of the game, or if we hit the back button on our controller, we drop out of the game. That's very handy to have in the early stages of development. Eventually you'll take that out, but we'll leave it in for now. And then down here, graphics device clear, that just sets up the rendering of the current frame to say start with a cornflower blue background. Let's go ahead and see what this looks like. There's a couple different ways we can run it. If you are a command line guy, you can actually open up the command line with control and the tick mark, or if you're on a Mac, command and the tick mark. Come on, terminal, why didn't you open there? There we go. And when I do that, also notice it's asking me, do I trust this folder? We want to go ahead and set up trust, and that allows things to run. So I can then say .NET, and you can notice as soon as I trusted it, now suddenly the language server is lighting up and highlighting everything. So if I do .NET run, this is going to run our game, and it should pop up here, and there it is. That is our game window. It has a cornflower blue background, and it's not really doing much of anything. Now, if you're a GUI person, there are a couple different ways you can do it from the GUI. The template wires in this VS Code, a launch.json, which has the instructions of how to actually run the game for the IDE, so that's taken care of for us. Let's see. So it gives us this button we can run, and notice it runs it there, and oops, we had a build failure. Interesting. I have an extra, must have typed something, hello game CS project, and that is on line, game 1, line 45. So if I jump back into game 1, look for line 45. Oh, I accidentally deleted something while we were hitting buttons. So that should have run just fine. And there we go. You can see it also ran. The third option is you can launch the debugging process from over here, and then that brings up a run button over here. So if you want to actually use debug mode and be able to watch variables and trigger breakpoints, you have to hook up the debugger and use it over there. Okay, so that is kind of the core. Let's get started. Now what we want to do is do something a little more interesting. So let's start by just playing around a little bit. What if we change this color? So this is an enumeration. There's a lot of different colors in here. We could do purple, and if I run the game now, we now have a purple background. Color also can we can construct it rather than using an enumeration. So if we construct a color object, we can supply a red, a green, and a blue value as floating point numbers or as integers from 0 to 255, or we could give a hex code. So there's a lot of ways to specify color. There's a couple other things I'm going to do, quality of life things. One of those is I'm going to come into this VS Code bin, and oh, did I get basketball there? That should have been in the content folder. Whoops, I'm going to move that to where it should be. I'll leave that there. Okay, so in our VS Code, we have assets should also be at the top level, not in the VS Code folder. I don't know how that ended up in there. So VS Code, we have launch.json, which is instructions for setting up the run button. I'm going to also add a settings here. And this allows me to set up some settings. I'm going to copy these from another project. I do not like all of the AI functionality that has been built into Visual Studio Code now. We can actually turn it all off. So this shuts off almost everything. When it doesn't shut off, this editor suggests on trigger characters, that's when I hit period. It should, for example, list all the properties of a class. I find that useful. The rest of this stuff really just generates a ton of noise and makes it hard for me to program and for students who are trying to program, because it tries to do a little too much for you, especially when you're first getting started. So I like to go ahead and just shut that off. And later on, when you pull the template projects, they'll have this preset for you, so you won't have to worry about it. But that just makes the coding experience a little bit easier for us, I believe. Other thing I'm going to do is, by default, the template always names your game Game 1. I'm going to go ahead and change that. So I'm going to change all occurrences, and I'm going to make this Hello Game to be a little more descriptive of what we're doing. And then I click off, and that should change everywhere. If we check in program, this didn't get changed, so we want to tweak it there too. And because it also used hello underscore game as the project name, I'm going to call this hello game example. If I could type, there we go. For the namespace, which means also in game here, I want to change this to, and that's just so that we're using camel case, which is kind of the convention for Visual Studio, or for C# code, just keeping with that convention. And then finally I'm going to rename this file to be hello game. So we got rid of all our game 1 instances. You can still use game 1. I just think it's a little cleaner if we have it reflect what our game actually is. And we can make sure that we didn't break anything when we did that. And boom, there we go. Didn't break anything. We got all the references changed, so that worked fine. Now we have this ball, and we'd like to bring it into our game. But there is a couple things about how XNA works. One of those is content files usually are not really in the best format for a game. So we can load them and pull them into a game and render them, but there's often a lot of information we don't need in there. It may not be organized exactly the way that would be most useful for a game. Often it's organized in a way that makes more sense for being an editor. So there is something called the content pipeline in XNA, which transforms assets into a finished form that we will use with the game. And that's what this content.mgcb file is. This is a listing of all the different content that we're working with and how it should be essentially compiled or transformed for use in the game. Now if we right click on open an MGCB editor, that gives us a GUI for editing that file, which is usually a lot easier to work with. And in this case, we need to add that ball. So we are going to import from the file menu, or not import, but no, right here. We're going to add. So go to the context menu for the content, and add. And we're going to add an existing item. And you notice the file browser goes ahead and drops us in our game at the content folder. We want to drop into that content folder and find our basketball and add that. And now we have the basketball sitting there. We also have some properties down here. And this is really kind of the important stuff. By and large, you can leave things with their default settings, but I want to point out there's an importer and a processor. So the importer actually opens the file and reads in its contents, and the processor does any pre-processing we need to do to get it ready for the use in our game. And then we have parameters that go with that processor. So this one, you can see there's a color key color. This, if you click on it, will bring you to a color picker. What that is a lot of times in a video game we'll have a sprite that's drawn in red, green, and blue. We don't have an alpha channel, so we want a color to stand in for this should be transparent. Magenta is a popular option for that, which is why magenta is the default color here. So if you pick a color and make sure that this color key is enabled as true, that's going to go ahead and, as it processes that image, replace all the magenta pixels with transparent black pixels so that it will be transparent in the game. So that's an easy way of pulling in some assets and cleaning them up and getting them ready to go. These other ones, generate bitmaps and make square, those have to do with graphics device processing, which we don't really need to worry about on a modern card for making square. It used to be graphics cards needed all textures to be square, so they had to have the same number of pixels on each side, width and height. That has not been a thing for quite a while. Generate bitmaps, that's really for when we're doing different levels of resolution. Things are at different distances from us. We can slip in a bitmap that is pre-processed and looks good at that scale. For 2D games, generally we're going to try to render our content on screen at the same resolution it was drawn, so that shouldn't be an issue either. So we can stay with all the default options there. And you notice that it says build output here. That's because this is actually its own project, and if we run build, it will go through and build everything that's listed in that project. You can see there we even get output saying, oh, I successfully built this. If it failed, there'll be some errors here that will hopefully guide you in figuring out what went wrong and how to fix it. So right now, if you pulled in an image, a PNG, a JPEG should all work fine. A GIF, I believe, works. There's a couple other formats that will take it, maybe a TIFF. And you can see here too that the actual underlying file was edited by the GUI. So now it has all of those properties set, as well as we're working on the basketball and we're doing all of those transformations to it. And if we were to build here, you'll actually see that build process gets run whenever we build the game. So you don't necessarily have to run it in the content builder, but that's a good way to debug it because you don't get all the good debugging code here in the main compiler. Okay, so now that we have created that basketball and made sure we pulled it into our game, we can now come in here and let's just add a private texture 2D. So this is a two-dimensional texture. And that's going to be the image, that ball image. And this class is defined in the graphics namespace, so we don't need to import it because it's already there by default. And we want to load it in this load content after the graphics device has been set up. So we'd say texture equals, and then we can use that content manager to load, and load is a template method, so we have to say exactly what kind of object we're loading. So a texture 2D, and then we give it the name of that file, which is basketball. And I say name, but it's actually a path. It's the path relative to the content folder or whatever we set as the root folder for the content manager. So because we drop this directly in content, it'll just be basketball. But as you get into bigger games, you may want to organize your assets around different things. So maybe level 1, level 2 is folders, and then inside just the stuff that's specific to those, however, whatever kind of organization makes sense to you. The other thing to notice is we don't have the .png extension in it, and that's because in the content build process, all of the extensions get stripped off, and what actually gets written out is then going to be a um, .x files. They all end up with the same extension. It also means you don't want two files that have the same name in there with different extensions, because they'll actually overwrite each other at the end of the day. And let's see, if we reveal in Finder, I can actually show you the binaries that we compiled when we ran that debug process. We should have... I might have to run the full build here. Notice now we have a content folder, and if we get in there, there's our .x and b file for that basketball. So that is the transformed file that will get bundled up with the game when we deploy it, but that is actually what we're loading. So it's not the original PNG, it's now that new transformed file that is in a format that is immediately usable by the game. Now we want to render that, so we're going to do that down here, and we're going to do that with that sprite batch object. And the sprite batch has some interesting aspects to it. One is we do all of our drawing between a sprite batch begin and a sprite batch end call. And that's because, as the name suggests, what it is actually doing is it will batch all of these commands, and then it will execute them on the graphics card in whatever way we have specified, so we can actually optimize that rendering process. So within that sprite batch begin and end, we're going to call draw, and we pass in what we're going to draw, so which texture we're going to do, and then where that's going to appear on screen, and we'll just do a new vector 2 and maybe 10 and 10, and then we give it a color, which is going to transform the existing sprite. It will overlay that color on the sprite. It'll basically just add it to the pixels that are there. White is going to be fully illuminated. It's not going to change the color at all, so that's a good default. And if we run this now, you can see there we have our ball. Now, it's a basketball. Maybe you want it to be orange. So if we change that color and run it again, you can see we now have an orange basketball on that purple background. So that's how we'd set up drawing. And let's go ahead and add a little bit of updating too. So let's actually create another private variable, a vector 2, so a 2-element vector. And this is going to be the position of our ball in the game world. And let's go ahead and set that to a random value in the initialize. So to get a random value, we need a random number generator. You've probably used system.random before. There is also one specific to X and A in the math helper. So we're going to use that one here, random. And I can construct it with a full constructor. I can also use the abbreviated constructor. I do need to give it a name though. And one of the things, we wouldn't normally construct it in a method and just do it as an instance variable in a class. We normally have one that's shared amongst the entire game and set it up as a property in the game. But since we're only ever using this once, it's fine to do it this way. And then I'm going to go ahead and set the position of that ball. So that position vector, set the position equals, we'll just construct a new vector, and one of the arguments it can take is basically floats, 2 floats. So I can say to that random dot new or random.next float, which will give us a floating point number, random.next float, which will give us two random numbers, give us a random position on the screen, and then down here, instead of drawing at new vector 1010, I'm going to use that position vector. Now, you might be wondering, what values are we going to get out of this next float? It's going to be a value between 0 and 1. So if I were to run this, it's not going to look like it's very far from the corner. In fact, every time I run it, even though it's a random number, our image is always going to appear at the corner because those vector values are measured in pixels. So we're saying basically between 0 and 1 pixels from the edge, which is not very far. Now we can actually use the graphics device, which is a property in the the actual game class, and get its viewport. That is how big our window actually is. So we can use the viewport width and multiply that by a float, and we do the same thing for the height, and that now will put us anywhere between the edge, left edge, and the bottom edge, and the top and the right. But because the graphics device is not initialized in our initialize function, we're going to have to move this code down here into our load content. So that is, again, why we have more than one initialize method. Is some things we can do in one place, some things we can do another. Now, we also need to move our math helper because we're not going to be able to access it if it's not up here, because that is just an instance variable. Or we could make it up here, which is probably what I would do if I was doing anything else with this, but this is just going to be a very simple example. So you can see now we're getting a different random position. Every time we run this, it's going to be in a different spot on the screen. Now let's make it a little more interesting. Let's make it a little more interactive. So let's add another private vector. So this is going to be the direction that our ball is going, and I'm going to do it down here just because I need that random number generator again. And this time I'm going to do 100 times and if you wanted to go faster, you can make it bigger than 100. If you wanted to go slower, you can pick whatever you want for that. But we're just going to add a direction. And then in our update, we can say our position plus equals that direction. And if we run this, it should now be moving at a random speed. We'll see how quick I am to get it. It's already off screen. It went very fast. 100 is a very, very fast thing. So what we probably want to do too is, because that's 100 pixels every frame, if you're doing your refresh rate at 1/30th of a second and I'm doing 1/60th of a second on my monitor, my game's going to run twice as fast as yours is, or my ball is going to fly twice as fast. How we fix that is we actually use this game time object here. So I could take the direction and multiply it by game time dot elapsed game time dot total seconds. So that's how many seconds as a double have elapsed between the previous frame and this frame, which will scale that number way down. And then I could put a float because this is a double, and everything else, and everything in X and A uses floats, so we do have to scale occasionally or cast things. So there you can see there's our ball, and went in a random direction, went off screen. Let's do it again. There, as it started in a different spot, it's going off screen again. Actually, I think every time we run it, we're going to see it's going to go in a downward direction. And that's because if we think about what we gave it for this random direction, it's always going to be a number between 0 and 100. So it's always positive. We can adjust that and say minus 50 on both of these. That basically says, okay, we're going to have a speed between negative 50 and positive 50 in the x, and negative 50 and positive 50 in the y. So that's going to give us going every direction. And there you can see we now have it going a different direction. And if I run this once more, hopefully we get a really good example of going a different way. There we go. So now we have it going down. So that's an easy way, and that's one of the tricks you have to really think about, is how do these different pieces fit together. Okay, let's do one more thing. Let's, after we've moved the ball, let's bounce our ball off the edges. So if our ball, our position dot x, so our x portion of that position is less than 0, so we've gone off the left side of the screen, or position.x is greater than, and we can use that graphics device viewport width. So we've gone off the right side of the screen. Let's take our direction vector and we'll multiply it by -1. So that will reverse the direction it's going. And then we can do the same thing for the y, or position.y is greater than. And one thing that is a common gotcha for students, the y-axis in x and a is in screen coordinates when we're working with 2D. So the y actually increases in a downward direction, which is not how things work in Cartesian coordinates in math. And the origin is in the upper left-hand corner of the window. And that has to do with how computer graphics actually got their start. They started with CRT monitors, which were made from televisions, which the old CRT televisions always started drawing from this upper left-hand corner and then scanned across the screen in reading order. So they would do lines going marching horizontally across the screen, and as a result we inherited a coordinate system which doesn't match our mathematical expectations. So now if we wait long enough, this ball will make its way off screen, and it should change its vertical direction once that y has gone past the edge of the screen. And there it is. Now you'll notice it went all the way off the screen, but up here in a moment when it bounces off this side, it will actually just bounce off this edge here. And that's because the origin that we're drawing the sprite at is actually the upper left-hand corner. Now we can override that when we draw the sprite, or we can just add it to our logic here and say, okay, we want to know, is it not quite off the screen? Is it just the width of the graphics device less the width of the texture, or height in this case? And the same here, which is one of the interesting things about the transformations that are done on those graphics. It makes the texture width and height immediately accessible to us as properties, which is very handy. And now it should, and it just did, it bounced off the wall there. It's moving very slowly. For demonstration purposes, let's speed that up quite a bit. So let's make that 300, 300, and make these 150. There, that gives us a bit faster moving of a ball. And there are other tricks you can play, like we could actually clamp the speed and then determine if it's negative or positive randomly. So we could actually clamp it to a range of like 100 to 200, and then say a choice of 1 or 2, it would be flipped in direction. So there are some tweaks we can do there, but that's pretty much gives us an interactive game that we can play with. We can see things working. We've got all the basics we need to start building some interactive games from this.